detail the real life implementation and also the application of iris recognition systems to understand their strength and weakness. And we will also discuss its security considerations. Iris recognitions and is regarded as the most reliable and accurate bioinformatics identification system holder. More detail, it will be explained by Dr. Anto. And Dr. Anto, time is yours.
Yeah, thank you very much for the times. My name is Anto Saprio Nugroho. Good morning, everybody. My talk today entitled Personal Identification using Biometric, using Iris. My name is Anto Saprio Nugroho. I'm working in Research Center for Artificial Intelligence and Cybersecurity in National Research and Innovation Agency. This is one slide to explain briefly about my CV. That currently I'm working in BRIN, National Research and Innovation Agency, and my research work on biometrics and image processing in pattern recognitions. I also active in Indonesian Association for Pattern Recognitions and also governing board member of International Association of Pattern Recognitions. My talk today is entitled Biometrics, specifically in iris. Actually, in our research organizations, in our Center for AI and Cybersecurity, we have conducted several topics of research activities. And in my research center, it is classified into three research groups: cybersecurity, machine learning, and computer visions. The topics that I will talk today is related to the computer visions of the AI. Here's the research groups in AI, in our research center. We have three research groups. First is computer and image processing, second is machine learning, and the third one is cybersecurity. For examples, in computer vision and image processing, we've conducted research on satellite data analysis, personal identification using biometrics, fungus identifications, disease diagnosis, a lot of topics related to the computer visions and image processing. In machine learning, we have conducted research on theoretical aspects and also application of machine learning. For example, prediction of driver conditions, micro electric vehicle autonomous or MEVI, auto, and so on. The research groups, cybersecurity, we've conducted research on cryptography, steganography, intrusion detection systems, and so on. In our research center, we have several collaboration internationally and also nationally. For example, we have international collaboration with Asia University of Taiwan related to the research on bioinformatics. Also, Zen Institute of Advanced Technology. Also, International Association of Pattern Recognition, University of Twente, and so on. In national collaboration, for example, with Research Center for TN Chikona, and also PSN, PSSN, and several institutions that we have collaboration with them. Okay, my talk is on the biometrics identifier. Biometrics definition is termed as this: automatic verification or identifications of individuals' identity using his or her physiological or behavioral characteristics. So, to information, physiological such as face, fingerprint, iris, and so on, and also behavioral characteristics. For example, the way people walking, making signatures, and voice. Here, if we talk about biometrics, actually, there are it is related to the authentication methods. There are three authentication methods based on what you have and what you know. For example, user ID, account ID card, and so on, and also password like when we try to log into Gmail, for example, we enter the password. But however, these informations can be shared, can be duplicated, can be cached, can be stolen. So different from those authentication methods, the third one is based on who you are. It is biometrics. For example, fingerprint, iris, face, palm, vein, and so on. It cannot be shared, it cannot be forgotten, it cannot be stolen or lost. The biometric solutions has several characteristics, reliable authentication and authorizations, but because mainly token or password of the object of authentication, not the users. But it can also show reputations, can be used for negative identifications, and also biometrics identifier cannot be shared, cannot be stolen, cannot be forgotten, and so on. Maybe a lot of our as
Recording in progress.
illustration about the iris. This is the our pupils in the center, and iris is around the pupils, and besides the iris is there is the white area of eye which is called as sclera. So iris is there is two boundary in iris. The first is inner boundary from eye from pupils to iris, and the second boundary is from iris to sclera. This is the second boundary. So like a donut. So actually when we have to cut the donut, yeah, of our eye, we try to extract it before we do some classifications. The first method of iris recognition is proposed by John Dogmans. This is the schema of the algorithms. It contains the subject identifier, iris localizations to identify the positions of eye, iris segmentations to extract the iris itself and ignore the other parts, and iris unwrapping, like if we have, for example, a donut like this, and we cut the bottoms and unwrap, yeah, to become squares, and followed by iris encodings and iris matchings. The first method for iris localizations is proposed by John Dogmans. This formula exposed by the John Dogmans that it tried to calculate the average Grill scales intensity of the circumference of a circles of radius s and center, and we try to find the two boundaries. The first boundary between pupils and iris, and the second boundary between the iris and sclera. Yeah. However, in this method, in each method of iris recognition, we assume that two circles are perfect circles and have one centers. It is to simplify the extractions, but actually it is not always correct. It will be developed in the other steps without assuming that both circles have the same same centers. In iris localizations, like I explained in the previous slides, the change in every grayscale's intensity of circumference of a circle is plotted, whereas in the radius are increasing. If the center is properly located, there will be two big changes in the intensity. For example, it can be seen in the graph when the pupil changes to iris and when iris changes to sclera. So these two positions is important to determine radius of the first circles and the second circles. For doing feature extractions, John Dogman used 2D Gabor wavelet to extract personal characteristics. 2D Gabor wavelet actually the formula can be seen from the slides. It has three components: the first, the second, and the third ones. The first component shows the oscillations on the directions of I. And the second components, using rho and beta and eta, it shows the spread in direction phi and spread in direction of rho. And these two informations between the previous ones and this one is combined to develop this graph, and this Gabor filter is used to extract the patterns of iris one persons. So as a result, this is the result of Gabor filters. It is the real part and also imaginary part of each extracted components. And we can see that this four informations form some quadrants. There are four informations, and the face of this is used as features to distinguish one person to the others. So we use the phase information, not the amplitudes. For examples, it is an input iris image. You can see the it is yeah yeah you can see the first boundary and the second boundary. It is almost we can see everything perfectly, although in reals sometimes it is cannot be seen, yeah, because of the other objects, yeah. First we do the segmentations, and we calculate the first radius and the second radius to extract the iris part, the eyes. The third, we unwrap, yeah, mm, from this segmented result to becomes rectangles or square, yeah. uh, and normalize this iris uh, to 120 to 8 rows. So there are 1024 informations. And we do the carbon filter extractions. We use the real of carbon filter using the convolutions, and this is the imaginary part. And as a result, it is the convolution result, real part and imaginary part. And as we calculate the combination of this as iris code, it is the most important information of a person to distinguish one person to the other. And we can use the informations to matching between two iris. For example, iris from one person to the other persons. We do the matching using this formula to, for example, this is the iris of one person, as this one is second person's. We try to find which of these two sequence have a difference, yeah. One, two, three, and four. Four cells are first, and it is the intersection between this. So 1, 2, 3, 4, 5, 7, 8, 9. 7, 8, yeah, around 8, yeah. So 4 out of 8, yeah, are different. So as a result, the Hamming distance are 4 out of 8, yeah, 0.5. This is one simple explanation about iris matchings. Iris matching applications, the famous application can be found in identifications of Afghanistan refugee. The name is Sharbatullah. Sharbatullah is an Afghan woman who became internationally recognized as the 12-year-old subject in Afghan girls. In 1984, the photo is taken by American photojournalist Steph Mary and published in National Geographic. It is this picture in 1984. Later on, the person is missing, and after 18 years in 2002, the same person is found, and to verify to make sure that he is the same person or not, the information of iris is calculated by John Dockmans. This is the picture, and the result is like this. It is the distance between the left iris and this one is the right iris. Left iris only has distance of 0.24. The right distance is 0.31. From the observations of John Dogman, he makes an observation of 2.3 meters different iris. The Hamming distance is plotted like this, and two different iris will have Hamming distance more than 0.33. So two different iris should more than 0.333 Hamming distance. Therefore, if two iris that has a distance of less than 0.33, it means that two iris come from the same person. Please take a look at the result of the first pictures of Sharpadula and second picture of Sharpadula. The distance is 0.324 and the second is 0.31. Both of iris distance is less than 0.33. Therefore, we can conclude that the two iris come from the same person. It means that this person in 1984 and this person in 2002, although the difference is 80 years, but we can show that they are the same persons. This story is very famous, and you can find in the YouTube and also in Google about Sarpagula case. In Indonesia, in 2015, I have the Indonesian police as researchers in scientific crime investigation study in 2015, and we've visited several Polres, kabupaten kota in Indonesia, and also in the same time we introduced Mangbis. Mangbis is mobile automated multi-biometric identification systems. So there are several biometric trait that can be used to identify persons. The fingerprints, the second is iris, and also face, I think. Yeah. This is one example using iris to identify persons.
Lebar. Lebar lagi, Pak. Motor Pak kayak orang marah, Pak. Oke. Sampun.
Dan hitung,
ya?
hitung.
Ya, sebentar.
Pak.
Sebentar. Nah, ini pencarian.
Ya, oke. Detik ke-50
Sudah, Pak ya.
Sudah.
11 detik, Pak. 11 detik.
Lebih cepat kan, Pak? Bener, Pak ya? Bener, Pak.
Oke, Pak.
Awet muda kan.
Sekarang putih, Pak.
Oke, coba Mas. Coba.
Yeah, so that is one example of how we use iris to identify persons. The iris information is captured using Mangbis, and the information is sent to the data centers of KTP Elektronik in Jakarta. Try to find persons with same iris, and the result is written back to the device to show the identity of persons. We have conducted research in using MMU1 datasets, Multimedia Malaysia University, using 40 class. This is the graph of showing the false match rate and false non-match rate. And this one is the binomial distribution of Hamming distance. And we calculate the entropy is 247. It is reported in our papers. They can be seen from the slides. We also make a comparison between gradient magnitudes and Fourier descriptor approximations. And gradient magnitudes produce a more detailed boundary compared to Fourier descriptor approximations. This is the one pictures. You can see the extraction of the boundary between iris and sclera is more details compared to the second method by Fourier descriptor approximations. This is the one demo, but I skipped this. We calculate also the discriminatory of iris. The discriminatory of iris is 3.2 bits per millimeter squares, and it means that 1 millimeter square of iris can be used to distinguish 2 to the power of 3.2. Let's say it is close to 9. 1 millimeter square can be used to differentiate 9 persons. Suppose the number of people's population in the world is 7.3 millions. I calculate that it is close. We only need actually 10.2 millimeter squares. It can be used to the all person in the world. Uh, this is the calculation of statistical variability of iris. The degree of freedom is 247. The Fitness figure is 2 Darwin result 249. This means that the probability of false match between iris of two persons is 1 of 2 to the power of 2.2 to the power of 249. It is much better compared to the iris and fingerprints. It is some of the our published papers and also standard that we have developed in 2021. As conclusions, we have conducted research on biometrics for personal identifications in fingerprint, face, and iris. But today I'm talking about iris only. The complexity and stability of iris have been studied. We know that the discriminatory entropy of iris is 0.2 bits per millimeter squares, and the degree of freedoms of iris is 247. It is close to the result obtained by John Bryan, 249. This means that the probability of false match between iris of two persons is 1 of 2 to the power of 249. Also, iris has reported the stability of iris, that iris images can be used for long-term identifications. We are doing the research on biometrics, fingerprint, face, and iris, and we believe that it is a kind of journey of 1,000 miles. Will begin with single steps, as said by Lord Lao Tzu. However, we want to do the best wherever we are as Habibie, dimanapun engkau berada, selalu menjadi yang terbaik dan upayakan selalu berikan yang terbaik dari yang bisa kita berikan. Thank you very much for your attention.
Very much, Dr. Anto. Let me read again the conclusions. If we have for identifications, if we use what we have, it can be stolen. If we use what we know, like PIN, it can be shared. It's not secure. If we use what we have is in a physical characteristics, who you are, he or her physical characteristic like iris cannot be stolen, cannot be shared, as more like a specific, because each person have their individual identifications like fingerprints and also iris. Face, iris, and fingerprints as a personal ID. It's common to use nowadays in the world, and also here in this room, Dr. Anto is one of the researchers that is very famous work in biometrics, especially iris and fingerprints. There are two boundaries, and we can imagine like a lens, and from the iris we can also unwrap, become rectangles, and we can find the score of the rectangles. It's less than 0.33, like Sabat Gula, Afghan girls. We can detect that the person is the same. It's a Sabat Gula, even though she's missing for 30 years, from 12 years old, and the iris is can detect very clear. For the audience in this room, if you have questions, you can raise your hand and we can have a discussion with the presenters. The first presenters, keynote speaker, Dr. Anto. Okay, one question for me. The computer will be checked in the Zoom if they have questions to Dr. Anto, and one question for me. If people already dead, I mean, body. we want to detect the human body. Is the iris still available to check, like fingerprints, or we can use iris only for people that is alive?
Basically, iris can be used for identifications of living persons, not
Only
for
living
the
persons.
so
Okay.
that person can be identified by iris. So in that case, we have to use different
Method,
modalities,
yeah.
fingerprints and
Fingerprints.
also face can be used for
Okay.
to identify
To
that
that
person.
persons. Okay. Why iris only used to identify for people that is living, like not dead persons? It's not accurate.
Yeah, because when a person is
Dead.
dead, it is difficult for us to extract the eyes actually. Yeah. Especially when it has been, let's say, 1 day, 2 day, or 3 days, the iris cannot be seen. And also, when the people will die, their pupils is
Getting smaller.
getting the pupils the size
Or
is is
different.
become yes different because become larger. Yeah.
Oh, okay.
So the iris information becomes smaller.
Oh,
So there
okay.
is the
So the area,
the area
the
of
radius
iris. Yes.
between one brace to the second brace is
Yes.
become smaller
Yes.
than when.
Yeah. Basically, the iris patterns change because of the size.
Okay, so for the identification of that person, it's better to use fingerprint.
Yes, fingerprints
Than
or
iris.
DNA for
Okay.
and also
Oh yeah,
face.
DNA. Yeah.
Depends on the case by case.
Yeah, even on case by case. Okay, one patient. Okay, 10 minutes left. Uh, in a Zoom, if you have a question to Dr. Anto about iris as a biometrics or personal identifications, you can write in the chat rooms. Okay. Uh, yeah. Okay. Oh, yeah.
Thank you very much for the opportunity. Dr. Anto, I would like to ask a question about in the era of generative AI, there's a increasing of face spoofing and also any kind of generated data that can be generated from existing data. Is there any kind of is the same thing happening in the iris recognition or something like that? Thank you.
Yeah. Uh, as far as I know, I did not see any paper using AI, yeah, for example, to make spoofing, yeah, iris. But in generative AI, perhaps can be used to do the feature extraction of iris, not to do as a spoofing. There are several papers on using deep learning, yeah, especially for the extraction of the face after the iris.
Except, thank you, Andiko. Except the Bohr filter, there are any kind of method that we can use to research in iris?
Yeah. I think you can use several methods. However, in Gabor physics, we try to evaluate actually not the amplitude but the phase passer, the phase as individual characteristic of person that we have used Gabor to extract the phase.
But Gabor is the best method for
Yes,
iris
yes.
identification.
Yes.
Okay. Okay. One question, Mr. Hari Praptoyo.
Thank you for a great presentation and insightful ideas for iris recognition. I have a question. What is the biggest obstacle from iris recognition in order to apply in like biometric application? Thank you.
Okay. Yeah. I think it is, yeah. One of the obstacles is the price of the scanners. It is much more expensive compared to the scanner for fingerprints uh, and also face. However, in just give one examples of the application of uh, iris is uh, wait a minute. It is one of the uh, yes in I don't know. Okay, it is one of the application of iris recognitions that can be identify persons of distance say
People
10
everywhere
meters.
are on the move, and identity
I will
management
skip
is
to
more important
the
than ever as we seek to strengthen global.
The most stable of all the biometrics on the human body.
Despite its superior accuracy, iris recognition has not been widely used because the technology was cumbersome and time-consuming, requiring users to stop, position themselves close to the camera, and remain there for several moments. Until now.
In the Sarnoff
this is one
system,
example
you're able to
using
move the
iris
camera
for
to be
overseas.
moving while they are being captured. With people all around the world more concerned about safety, Sarnoff's Iris on the Move system provides accurate identification without being invasive to the individual.
Sarnoff provides a technology solution whose time has come.
Why Sarnoff? Our cutting-edge technology delivers the security of iris recognition in a fast, convenient, high-throughput solution.
It is one example of using iris for iris on the move.
With a processing
Actually,
speed
I want to develop. I want to study this kind of method used for to identify a person from distance. However, the scanner is very expensive compared to the fingerprint and
Or face
or face
recognition.
recognition.
Yeah.
UPN can buy scanners.
Again,
I would like to
research
join
with
research.
Yeah. Okay. Thank you very much, Sir Ansel, for the answer to Mr. Hari Praptoyo. The conclusion is still a big challenge to develop iris identifications because of the yeah, we have an obstacles, especially for the price, yeah, compared to fingerprints and face recognition is more cheap than we develop iris and iris. Okay, I think it's enough for this first session for the first keynote speakers. Audience, please give an applause to our first speaker, very nice and very good explanations. And the end of these sessions, we have a souvenir for you. And Mr. Awang, as the head of informatics department, will come to the stage, Mr. Awang, to give the souvenir to our first keynote speakers. Give applause. Thank you, Dr. Anto Satrio Nugroho, from the head of Research Center for Artificial Intelligence and Cybersecurity, National Research and Innovation Agency of Indonesia, BRIN. Thank you again, Dr. Anton.
Thank you so much for Mr. Anto and Mrs. Helena for delivering the insightful knowledge that related with personal identification using Iris. And yeah, I hope all of the participants get a lot of knowledge and there are things that can be implemented in the future. So
Moving forward, we have Associate Professor, Technologies Professional, Dr. Muhammad Sanusi Asmi, that will be moderated by Dr. Awang Hendrianto, STMT. For both parties are welcome to present and the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Everyone can hear me or not?
Yes, I'm here. Thank you,
Can you
Dr.
hear me, Dr.
Sanusi.
Awang?
Wait, I will introduce myself.
Okay, good.
Okay, thank you from Dr. Sanusi. Dr. Sanusi is the Dean of the Faculty Technology Management and Communication, University Technical Malaysia Melaka. And then Dr. Sanusi has graduated in University Kebangsaan Malaysia for the PhD, Master, and Sarjana. And then many research that Associate Professor Sanusi has got from the publication in international conference and many publications. Today, Associate Professor Sanusi Asmi will present about accelerating research through artificial intelligence. So it's time for yours. Thank you. This is
And good afternoon. Thank you to Dr. Awang Hendrianto, my friends, respected ICAI's 2013 committee, professors, doctors, presenters, and all participants of ICAI's 2023. My name is Sanusi Azmi. Currently, I am the Dean of FICTS, University Technical Malaysia Melaka, and my research area is in image processing, especially on the features extraction. Okay. This is our university. Our university is located in the Melaka Heritage City. It's around 1.5 hours from Kuala Lumpur and 1 and 15 minutes from KLIA. Okay. So before we proceed to our topic, I just want to give a scenario. And the scenario is, in the era of computer invention, we cannot say, do not use computers. Because what we type on a computer can be copied to another computer. We should continue using typewriters. In the age of cloud computing now, we say that using cloud computing is dangerous because our data might be compromised. We should only use thumb drive. And then what will happen if we reject change and resist technology? So if we reject change and resist technology, we may miss out on opportunities to leverage advancement and convenience offered by technology development, and we might bound by outdated method that may no longer be efficient or practical. Therefore, it is important to open to change to understand how the technology can enhance our daily life. Okay, this is our topic. Assertive research using AI means that I just want to give another example. We want to deliver pizza, okay, from shop to home. If we are still using, if we want to walk from the shop to the home, or we just using the bicycle without using the motorcycles or without using car, means that when when the pizza delivered to home, means that it's already not hot and it's already outdated and so on. That's why today we have to leverage our research by using an AI. And we have to leverage, we have use and we have adopt research by using AI. Then AI is what introduced by John McCarthy et al. In 1955. And AI actually is a software that can imitate human, imitate human to do what human do. Example, reasoning, learning, decision making, perception, identify pattern, detect trends, and make accurate decision. This is AI. AI is already taught a long ago in 1955, but on the November 2022, when the first ChatGPT is introduced to the users and followed by big AI and BART and so on, then the usage of AI is increment tremendously, and then they help a lot of people, including us, in research. So there are two types of AI. First is a narrow AI. Narrow AI, like if you use the phone, like a Siri, and if you use a chatbot like ChatGPT, BART, and so on. If you are using Weka, if you are using machine learning software, if you are using autonomous vehicle like Tesla and so on, email, spam filtering, and so on. And then it's for the network filtering. All is a narrow AI. But the narrow AI is still yet not matured enough. And then after the narrow AI, we hope that there will become general AI or general artificial intelligence that is hypothetically type of AI that has the same ability to the human to understand and the reason at the level as human, but general AI does not yet exist. So we have two narrow AI. Means that narrow AI is like the AI by module, But general AI is all the modules we combine it together, we become one human that imitate the human. And then Bill Gates says AI is a pretty dumb, but will predict in 5 years. In 5 years, everyone will have the robot AI agent. And then he think that AI, like ChatGPT, is the most important innovation right now. And AI is the most innovation right now. And then Mark Zuckerberg says AI is going to make our life better in the future. In the next 5 to 10 years, AI is going to deliver so many improvements in the quality of our life. That is what Bill Gates, Mark Zuckerberg says about AI. They already predicted in 5 to 10 years, everything will become advance, and so on, and our life and the quality of life will become better by using the AI. Then we are in Asia, we need to grab this opportunity, to use AI in our life. And then I believe with the president of Indonesia, if in this research, if we are using AI, we become the leader of the research. For the president Jokowi said, Indonesia has to accelerate AI capabilities. Is in the race with other countries to control AI. Whichever country controls AI can potentially control the world. Means that for the research, it's the same situation for the country and also the research. If you do the research, but you are do manually and so on, this is become slower. Like we want to deliver the pizza from one point to another point. If we are walking, will be slow. But if you are use technology, become faster. But the content is the knowledge that you want to deliver. That is why AI is very important, and for the Asian, for the universities, the faculties, we need to embrace AI, and we need to embrace AI, and then we need to make sure we lead the AI in our faculty or in our country. And next is Joe Biden. When the AI come to the pictures and come to our life, there will become some trade-off, some security concern and so on. Means that for the American, for the Joe Biden, the president of America, Joe Biden has predicted, and they want the new executive order to control the AI in order to make sure people are using AI in the correct manners. And this is referred to the cbc.ca on the 30 October 2023. So, how? This is AI adoption game and training. 24.6 of organization in Indonesia adopting AI. The country lead the pack in terms of adoption, followed by Thailand, 71.1, and Singapore, 9.9, and Malaysia, 8.1%. For the adoption, AI, Indonesia as lead on this, based on the digitalnewsasia.com and Disruptive Asia. Congratulations to the Indonesia. And then, the proportion of upper business using AI in their operation jumped from 39% in 2020 and 21 up to 76% last year. This is the report by the Tech in Asia. Means that from 39 to 76% last year on the APEC business that using AI. There is a very tremendous and there is a very high increment on using the AI. AI platform will be the fastest growing software between 2022 and 2026. And then in Southeast Asia, especially spending on AI solution is predicted to increase from $1.174 million to $6.6 million in 2026. The market of this tech is also projected to have an annual growth rate of 40.8% from 2021 to 2026. This is predicted on the economic parts. Means that from 174 million, they will up to 646 million in Asia. So this is the report in McKinsey report in 2017. In 2016, from the report, the company invested AI is 26 billion to 39 billion. This is 2016. But ChatGPT is started on November 2022. I believe that the more company they are Microsoft invest billion on the ChatGPT and so on. And then startup now is billion to 6 billion, tech giant 20 billion to 30 billion, and 3 times external investment goes since 2013. So we can see this figure, okay. India is a AI adoption level by sectors and country within Asia. we can see the darkest is the highest, relatively high. Means that you can see is Indonesia is on the very good points in medium, and also for other country and Malaysia and so on. For Vietnam is a very relatively high on the AI and so on. This is what the AI addition model in Asian 2017. I do not get any report on 2022 and yet 2023. Means that in 2022, I believe, starting from the November 2022, the adoption model on AI is tremendous. There are some company in Malaysia, they told us we can decrease the workers because of, if we want to write, we can use this GPT. If we want to do the paraphrasing and so on, we use Quill and so on. If we want to use uh, summary of paper and so on, we use this AI and so on. Means that they can reduce 3 to 4 staff to do that everything. Okay, so research at the higher education level in ICT. And for me, as a dean, we are looking on the research. We are looking how we want to accelerate the research. Okay, so that in the AI means that from the previous one, from 34% to 70%, means that they are almost more than double increment. Supposed to be in 2023, our research, our publication should be increased double from the last year because of the AI. If we are not double our research or application and so on, means that we are not yet leverage the usage of AI. We are not yet adopt the technology of AI. There are many things in the research of AI: data analysis, pre-processing, natural language, data review, and so on. So this is some workshop happened in UTM. It's a microwave research group. They held one workshop for hands-on review paper writing using how they write the paper review using the chat GPT, how they use it one in the correct way, in the very ethic way, to produce a lot of research paper. Why we need a research paper actually? First, we want to distribute the knowledge to the world. Then the second one is why we need a research paper. The second one, we want to show the people that we are produce this research, we are doing this research and so on. And then, why do we need the AI in the research? First, for me actually, first, we are not native English speakers. Most of the international journal, most of the international journal, most of the collaboration, most of the memorandum of understanding, memorandum of agreement and so on are all in English. There are a lot of very excellent people doing in technical thing, doing very good research, but they had a problem with English. However, that it doesn't mean they are not good. They are very, very good in research. But in order to write the research paper in English, they have some problem. If you use the translator and so on, by using the, let's say, example, Google Translate, there is not nice and there is not very correct translation and so on. And then, review the time spent finding the best keyword, eliciting the process of obtaining research paper inside. So we can have the papers, we just drop it into this AI, then we summarize the paper, what is the objective, what is the problem, what is the result, why the result, what and so on. Then what is the summary of the papers and so on. That one I not yet use that one. Okay, for that one because I'm still conventional. I read the paper. For the paper, I extract by myself. But that will take a lot of time. Okay? Because to understand the paper, at least if my field, I will take 1 to 2 days to understand everything. But if the paper is 10 pages, 15 pages, we need to take more than 10 days and so on in order to understand it thoroughly. And the part one is we can skip the proofreader. And the proofreader reduce time spent reviewing and submitting article, reduce the time required to convert formulas into pseudocode and source code. Many things. And because I during my PhD, I produce one technique, my technique. So sometimes before I redo the technique, I need a lot of algorithm and so on. Some of them I write by myself, based refer on the algorithm and so on. But this takes a lot of time. I test and then I write the coding, then I test. Is it produce the correct output and so on? I need to validate and so on. Although that is not my contribution. So now I just start. Let's say I want the also algorithm. Also algorithm. Let's say I want to the Euclidean distance method or Sorensen method and so on. Or what I want to do the hierarchical features and so on. I just do and then I see the code or that one. Then I switch with my code because that one is not my contribution of the research. Because before I do my contribution, I need to undergo that process first. Okay, now so is AI enjoyable in research? First, there must be a personal touch, such as our own sentence. Some people in Asia, they like to write in Bahasa first, and then they translate. Some of the unethical, they just give the point, please write based on this point. That one is not good. Okay? I have some experience when I want to give a speech, when I did, oh, this not very nice because it's when they are generated by AI, normally the texts are overclean. And then they use the English that normally is seldomly used by the, so we not use the bombastic word. So wow, so I know this is AI. This is AI. Then I not feel very enjoy to read the text and so on. The structure and arrangement of content for research should be determined by us. If everything is generated by AI, it becomes uninteresting, monotonous to read due to the repetitive patterns. Okay, AI, although they produce can give that one, they can give the output of what we want, but it's a monotonous and it's a repetitive pattern. Okay, sometimes we are okay with our pattern, although that is not as good as AI generated, but we think this is our our works and so on. And then is enjoyable in is AI very enjoyable in research? They must be personal type. Oh, this one I already covered. My experience in writing research proposal. First, writing research title, I am more comfortable generating ideas and exploring research topic in my mother tongue through writing and contemplation. Means that I'm using the ChatGPT. Translate penambahbaikan kaedah filter segitiga berasaskan zoning dalam meningkatkan kecepatan. So, then the ChatGPT gives the suggestion improvement of the triangle features method based on the zoning to enhance accuracy. So this is what I think in my mother tongue. Okay. So the second one is suggest similar titles. Suggest similar titles. So I get a few titles by the ChatGPT, enhancement accuracy, refinement of triangle method, and so on. Okay, we can generate many things, the ideas. Okay, actually the first one is my thesis title. Then I want to know what enhancement can I make for my thesis and so on. This is some enhancement topic that can be used to get another topic of the research and so on. Okay, now writing an executive summary or abstract. So as before I said, I am more comfortable writing the abstract by myself, which include 7 things: introduction, problem of existing research, objective, methodology, data set, experiment setup, result or expected result, summary and discussion. Then I will use the AI to correct the grammar. This is what I did. Okay. I write everything. Either I read in English or I read in Malay, and then I use the ChatGPT to correct the grammar. Because of why? Grammar is very important. Sometimes we want to mention about one, but the grammar is many. Then there will be a misunderstanding and so on. And then AI that is generated by the abstract that's generated by the AI is overclaiming. So that is not have the feeling of wanting to read it. Then you use the AI, 100% you rely on AI, that is overclaiming, then monotonous. So next is writing literature review. Use SI to extract the critical point from existing research. Summarize research paper before focusing into the target research. You utilize AI for translating your writing and employ AI for paraphrasing sentences. Sometimes we need to do paraphrasing and so on. Yes, we can make it as a teacher. Sometimes I really don't know. We write the English one. When we go to the Turnitin, then it are same to others. Although we are not copy from the source. So what we need to do? So we can copy that sentence, then we ask the Bard or Bing or ChatGPT to paraphrasing the sentence or suggest other sentence like that one. Then we can suggest a different sentence based on the what we give. Okay, so this one, and the second one is we can generating the milestone. And sometimes we want to make it in hurry. Okay, so I want to give you a project, but you need to submit in. You get it at 9, then you need to submit by today. So sometimes you can use the GPT to get the suggestion where I can start and so on. For me, here is a sample. Create software development milestone Gantt chart based on agile for 6 months project. And then they will give this one. Okay, then complete not stated and so on. And then you can modify it or you can switch with the content with your own project and so on. And then research milestone, example 1, instruction with specific tasks using ChatGPT. Generate research milestone for a 2 years research project starting from January 2024. The milestone and Gantt chart include the following. So I get 4 months of research, 3 months for developing research framework, 2 months for research setup, 6 months and so on. And then they will give you the suggestion. This is, for me, it's just a suggestion. Then for me, if I get the suggestion, I will change everything. Okay, I already get the idea what to do. Then what the key that I want to use in my key concept I want to use in my literature to find the teacher based on this research, let's say in the picture section for using the geometry and so on, and then using the statistical approach and so on from 2017 onwards, let's say. And then the second one is I'm using BART to generate research milestone for 2 years. Research, that one is by using BART and so on. Then I will change this one, duration. And then we can create pseudocode from simple instruction. Example, write pseudocode, input array of double, process, find the maximum value and the location of the maximum value, output maximum value and the location of the maximum value. So we'll get this one. This is the pseudocode. Why we need pseudocode? In thesis, we cannot include source code. We must provide the pseudocode or algorithm. We cannot give the source code in the thesis, just a pseudocode. This is an example. Okay, so actually we have something because it's the process of research. Before you do your own contribution, there are some method that you need to apply. Either there are 3 ways. You get it from the authors of the method, or you translate the pseudocode from the papers and so on to the coding, or the third one is now from the pseudocode that are given in the coding in the papers, you convert it to the source code and so on. Okay, now, so leverage AI to develop pseudocode from code. Okay, So for me, this one is algorithm written by me lah for the calculate Sorensen algorithm and calculate distance. Okay, then I want to do a pseudocode. Then I just type write the pseudocode from the source code. For the source code, then I minus. Then they will generate this one. Test represented one, output is what, class is what, and so on. They will translate to the pseudocode. And the second one, generating pseudocode from a formula. Implementation of code can be generated from a mathematical formula. Okay, we give write pseudocode for this formula based on number of array sum. Then I give that one. So automatically they will create the Euclidean distance formula. And this is the Euclidean distance. Then they will generate the pseudocode for you. And they will generate the pseudocode for us. And also, they also can generate the pseudocode for you, either for Python, for Java, or C++, and so on. So this part, in my thesis, not my contribution, Euclidean distance. But I apply my features, my proposed features with two types. One, I'm using the support vector machine and neural network, and for the one for the supervision. The second one is I apply the distance, and then I see the distance is not very good because of it's a false identification. What I did is with this Euclidean distance, Sorensen, and so on, I use also the mean average position in order to get a better results. Okay, so now finding or generating source code from an algorithm. For why we use the AI? Because we want to benchmarking the result, enhancing the existing algorithm, exclude implementation that are not part of your research, of our research contribution. That's why last time on 2010, I did my PhD. Many of the algorithm I need to write by myself. I need to write by myself. Exclude WK lah for support vector machine. I just apply. But for the distance and so on, I write the coding by myself in order to check it with the data, to check it, the result and so on. That's why I think this year, if we do the research, many part of the process, we can reduce a lot. Means that if the performance is double, okay, the weightage or the burden of doing the research is less by 2 times, less by at least by 2 times in do the research. And then consider the aspect before finalizing and submitting your research proposal, papers or reports. Okay, double check the advice from AI, as AI is based on the trained model. Consequently, the results are entirely reliant on the model, which may introduce bias. Sometimes when we check out using the ChatGPT, for the Bing is okay, they provide the citation from where the text is come from. Then basically I check that one is number one. Then I check I click that one. Then I can see the people said, oh no, there is no, the people in that article don't say like what the GPT suggests. Then I need to double check. For that content and so on. We have to double check. Okay, all the data that introduced, they say is 34% to 74%. Then you need to open the document. You need to see is it correct or not. Okay, because of we are the academician, we are researchers. We must produce. We must produce the correct data and so on. So that make modification to suit your own writing style and presentation of data. This help is establishing recognition for your work. Sometimes we have our own style, our own structures and so on, and we just need to follow with our own style. If we follow the ChatGPT style, then it's something is very not good and so on. That's why we have to do modification and so on. And then always leverage for productivity and disseminating knowledge in research and papers. Means that always, for me as a dean, I always ask our staff to leverage the usage of AI in research and many things ethically, ethically. So the issue is too many requests in 1 hours means that it's very good. The open version has limitation on the number of prompts and so on. Advanced and unlimited features require a subscription, so you need to pay and so on. And for me, we have the big AI. This is subscribed by our university, so we can use this unlimited. And then the bad thing is expose your behavior to the AI system. They can be manipulated and abused by AI. This is the worst case scenario. But we are not very important person. We are not the ministers. We are not the army and so on. So that is not a big issue on this part, on that one, because of we have by hook and by crook, we need to move. We need to embrace the technology of AI in our daily life. And then AI cannot be sidelined. Speed is crucial, and AI is tool. Nowadays, if we slow 1 minute, then we will slow many years. Okay, the president of Indonesia, whoever master AI has the potential to control the world. Means that if we can embrace the AI in your research and many things, means that you can be good researchers and so on. Business growth could exceed $900 billion. Adoption by small and medium business can reduce costs and increase productivity. New job opportunities include using AI for creating multilingual poster, business forecasting, report generating, clerical tasks, and specialized AI agent. And then AI can add researchers at the global level. Means that I believe not just in Indonesia, in Malaysia, there are many researchers are very good, but they have a problem when it's come to the writing, to the English, or to the technical paper. So AI can accelerate the research process. Most data process can be handled using AI ethically. Proposal preparation, progress report, and final report can be produced quickly. More journal papers can be produced with the help of AI. And that's all. Thank you.
Thank you. Associate Professor Sanusi Asmi is interesting topic, how to speed up the research using artificial intelligence. So the research can speed up, can be speed up, like use GPT for the preparation proposal, and how can AI can be translated from the process, the application, and how develop the program from the formula, and many can be using the AI for the effectiveness for the research. Maybe we can create a workshop for how can maximize research using AI. So if any question, please, yes, Dr. Helena. Okay.
Thank you, Dr. Awang and Dr. Sanusi. Dr. Sanusi, thank you very much for your research in the AI area, so it can enrich the AI research. My question is, you said before that we have kind of pyramids for artificial intelligence. The first or the ground layer of the pyramids, it's about weak AI or narrow AI. And the second layer, we talk about general AI or strong AI. And the top layer is strong AI. Not strong AI, a super AI for the top layer of the pyramids. Nowadays, we are in the narrow AI. GPT, it's not mature yet. is still in the area of narrow AI or the ground of the pyramids of AI. My question is, AI nowadays in a golden area,
Yes,
but
exactly.
we never forget the history of AI. It's famous. We call it the winter AI because there are many criticals from the researchers in 1973 to 1980 something because of the criticals from the researcher and also the failure of the project of AI and the funding from the country to develop the project of AI, and AI is stopped. In 1973, it's about 20 years, and we call it the winter of AI. Back to the pyramids of narrow, general AI, and super AI. Uh, I agree with your research that AI is still develops, and we are in the AI that not mature yet. And in my mind that AI probably okay receive the criticals like ChatGPT in the education area, no one can predict that there will be the of AI because of AI is not. Yeah, I can say that this can disrupt many ways of education, especially yeah we use ChatGPT or something to not for a good ways. Thank you.
Okay. So for me, maybe the question is not very clear because of the transmission with the data. But what I understand is what doctor said is they are very good and bad of using the AI. Correct? So what I understand is actually like we use the knife. Knife is very good actually, but if you are doing the wrong things, knife will become bad impact to the to the life and so on. Same like the AI. Okay, the problem is now for me lah, uh, with the person of above 40 and so on, with the faculty members or UTIS members and the research network and so on. Actually, what we need, what I want to emphasize on my lecture note is we have to embrace, although we are very good writing programming, we are very good in writing proposal and so on. We have to take the positive side of AI. We have to maximize AI to maximum level of AI. Okay, with the ethics in order to make sure that we can be a good researchers and we can publish more papers and we can apply a lot of journal. Mhm. And this is my opinion. Actually, the question is not very clear because of noise between the transmission. Maybe Dr. Awang can
Very
help
clear.
me.
Many one more question. Okay. After Miss finish, and then okay, please.
Okay, thank you,
Oh,
Thank you, Dr. Awang and Dr. Sani. I have a question about ML algorithm is a brand of AI that focus on developing algorithm that allow system to learn from data. I have a question about how ML algorithm can save energy in the training phase and system testing phase if AI for image processing. Thank you.
Actually, for the actually I try. lot of the algorithm.
Excuse me, one more question from this one.
Okay.
Again.
Last question.
Yes, sir.
Okay, thank you, Mr. Sanusi, for the opportunity. My name is Febrian Wisnu from University of Lampung.
Okay.
Yeah, as a journal editor, we we have a standard for the similarity of article that submit is under 28%. If we using authenticate, the AI scan is appear in the measurement. Now, in your opinion, how can we suggest that some of the article is good or not based on the AI measurement? Because if you're using ChatGPT or using Quillbot, using Grammarly, it will appear that the article
I understand. Okay. So I answer the other question. Okay, I answered the first one and second one. So the first one is actually for the image processing. Actually, for the first thing is there are a lot of algorithms that we can find by using the Chat GPT, but uh, uh, Bing AI and so on. However, if we are not good enough, okay, you cannot implement that algorithm to the code. Okay, we cannot implement the algorithm to the code because of normally all the complex algorithm, they are dependent on the third party library. Instead, we need to a lot of license. You cannot run that one. That's why the foundation of the skill is very important. Okay, but if already we have the skill and it becomes easier. And then the second one is question is about the AI. That's why I and so on, they based on template they apply the concept of similarity. That's why for my paper actually I prefer to write my own words, then I check the grammars, or maybe sometimes I write in Bahasa Malaysia or Bahasa Melayu. I write in Bahasa Melayu something that thing, and then I do the translation only. I not ask the ChatGPT to write the sentence for me because of they will problem with the ChatGPT. And then the first thing that we need to know, the first thing is why we publish paper. This is my concern. And why we publish paper? I mean, because of we want to deliver our our, our invention, our contribution to the world. That is the purpose of we want to publish to the paper. And then normally we write the paper because of that is our work. Because that is our work. And then I believe that some student actually for my student, I ask her and him, ibu boleh tulis bahasa Malaysia dulu ibu. Jangan tulis bahasa Inggeris terus. Ibu tulis bahasa Indonesia, ibu terus gunakan chat ke apa, ibu terus saja. Will be different and so on. But when they write in their native language, write their mother language, then you can see when they translate to English, wow, now I understand. Wow, that is very good. That is very good. call the body of each. Okay, and then yes, we can ask the ChatGPT to write the sentence based on we just list. Write a paper that include this one, include. Then it's not very nice. For me, I prefer to write it and then I check the grammar and so on to make it faster. Sometimes and then if I have that mathematical formula that I use that I want to combine that one, I ask them to combine to the algorithm of pseudocode. Then from the pseudocode, I try to switch with 2 on 3, and then I 2 or 3. Then I mix it and make it easy to understand. And with my sidechain of writing the pseudocode, not the pseudocode sidechain. I have my own sidechain. Okay. All right. Okay, that's all, Dr. Awang.
Sound I second.
Okay. Thank you for Dr. Associate Professor Dr. Sanusi. Please give big applause for see you again. I hope we can offline in Yogyakarta. I'm waiting you for the workshop.
Inshallah.
So the implementation ChatGPT.
Inshallah. Sure, inshallah. Thank you, Dr. Awang. Assalamualaikum.
Okay. I waiting you and come to Yogyakarta.
Inshallah.
See you.
See you.
Thank you for the presentation from Dr. Sanusi and for the moderator. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you so much for Professor Muhammad Shasmi and Dr. Awang Yulianto that already delivering about artificial intelligence. And I think that's all for the second speakers of this session.
Moving forward, we will have lunch break. Our lunch break will last for 75 minutes, giving you sample time to enjoy a delicious meal and engage in conversation with your peers. We will reconvene promptly at 1 p.m. for the next engaging session on our agenda. Thank you.
So much.
Recording in
gentlemen,
progress.
thank you again. We are joining to the conference Erlina Jaydianti. It is such an honor for me to speak on behalf of the organizer as a moderator for this event. Okay, let me begin to read the brief curriculum vitae of Professor Dr. Tom Satrio Prabu. Okay, let me read for the professional experience. Professor Dr. Anton Satria Prabowo is a professor of King Abdulaziz University, Saudi Arabia from 2016 until now. Present and Associate Professor, King Abdulaziz University, Saudi Arabia, 2013 until 2016. Head of Industrial Computing 2012 to 2013, Associate Professor of University Bangsa Indonesia 2011 to 2013. And as a publications, I will read one or two publications and community service of Professor Anton, book chapter, book eight books and 19 book chapter, 107 journal articles, 93 per conference, and as a keynote speaker or invited talk, 71, and as a supervisor for 16 PhD graduated and 35 master graduated. Professor Anton, time is yours to present your topic today.
All right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning here, good afternoon in Indonesia, Yogyakarta. So thank you to Dr. Helena, as the moderator. And first of all, I would like to thank you to the organizing committee that inviting me to deliver a speech today, in this conference. So let me share my slide. All right, so can you see the slide in your side? And can you confirm that the slide is shown in your side?
Very clear.
All right, okay. So thank you. All right, so again, thank you very much for inviting me to deliver a speech in the first international conference on advanced informatics and intelligent information system, ICAI 3S 2023, hosted by Universitas Pembangunan Nasional Veteran Jakarta, Indonesia. Right, so my name is Anton Satria Prabowo. I am a professor in the Faculty of Computing and Information Technology in Arabic, King Abdulaziz University, and also visiting professor in School of Computing and Informatics, University Technology Brunei. The first in Saudi Arabia, the second one in Brunei Darussalam. All right, so my collaborator was Ihsan Golkar in University of Pennsylvania, United States. All right, so the speech today is entitled Vision-Based Surface Defect and Flatness Inspection for Ceramic Tile Edges. Right, so it can be categorized as the computer vision, and image processing, and as well as in artificial intelligence. Right. So the outline of my presentation today cover as the following: introduction. As usual, I'm going to introduce about the visual inspection, machine vision, actually, and then some related works, in order to strengthen of the research contribution, and then problem background, I'm going to explain about the background that is happening in the real case, or in our studies, and then continue with the research objectives, yeah, and then will be followed by the methodology. So in this case, I'm going to explain about the software part, yeah, that will be involved, yeah, or developed, yeah, in order to provide the vision-based, yeah, flat surface defect and flatness inspection. And then the result, yeah, generated from our research and as well as the conclusion. Yeah, all right. So the next is about the introduction. Yeah. And then, yeah, the technology of vision computing, like machine vision, actually improves the productivity and quality management, and as well as provides a competitive advantage, yeah, for the industries that implemented this kind of technology. Yeah, if we compare this technology with the manual or traditional one, so it will give a more beneficial and also the competitive advantage, yeah, for the industries. And then the structure of machine vision, as we can see here, yeah, the machine vision, yeah, it consists of the camera, the first one. Yeah, you can say this are mainly for the hardware part, right? So the structure of the machine vision. So the camera, the first one here. Yeah, so any camera we can install, but if we are going to get the good results, so of course we need the high resolution or high performance camera, yeah, high resolution camera, high end technology, yeah, like CCD camera, yeah, charge coupled device camera, yeah, so mostly used in high tech, high end manufacturing process. And then second one, we need also the illumination or lighting. Yeah, so in order to compensate the lighting effect of the environment, so we need the on illumination system or lighting system here. So we can get the clear image, yeah, because of the environmental lighting also effect to the overall process and will effect to the result of the the inspection as well. Right, and then the main processor, yeah, so it involves the computer, yeah, of course, we can use a personal computer or uh, notebook, yeah. So then which one more suitable, yeah, for the mobility? I mean, if we need to install this kind of application in different places, so then we can use the mobile devices. But if not, then we can use the permanent one, yeah, or the fixed devices that install in our system. But and then the manufacturing process here. So usually we use the conveyor belt, which is moving from the right to left or to left to the right. So it is a moving object. So then we capture the object on the top of the conveyor, yeah, in order to be processed or to be processed in the next step of the image processing. And then, of course, the last one is about the software part. Yeah. So this we can consider the hardware. And then the last one, image processing, is the software. All right, so then in the software part, yeah, the image processing, yeah, it consists of the image acquisition. This is the first step of the image processing. Yeah, so we take a picture, yeah, capture the image by using the camera, yeah, as mentioned here. So we can use the CCD or CMOS camera, the normal webcam. In our experiment, we use normal webcam, yeah, the web camera, yeah, which is of course the low price in if we compare with the high-end technology camera like CCD. So the price will be very, very affordable, yeah, if compared to the high-end technology. Right, and then after image acquisition, after we taken some pictures, yeah, images from by using the camera, yeah, from the real object, and then we go to the pre-processing step. Yeah, pre-processing step consists of the smoothing part. Yeah, so we eliminate some noises. Yeah, enhance the features, yeah, or the picture. Yeah, so we enhance the image, and after that apply some filtering process in order to get the object itself. Yeah, because we need to subtract the background from the object, yeah, in this case. Right, and then after smoothing, so we get the smooth image and proceed with the segmentation. So we segmenting the part of the object, yeah, and then we get some part that we are focusing on, yeah. So then after that, go to the filtering, yeah, for the next process of the pre-processing. Yeah? And then after we got the results from the pre-processing, we put the result as the input of the feature extraction. So in this case, we have to determine what kind of the features will be implemented in the process. Yeah. So for example, in this case, we determine the length. Yeah. The length means that the size, yeah, the distance of the objects. Yeah. And the surface defect. Yeah. So then surface defect we can categorize in some kind of the defects, yeah, like blob, welt defects, and so on. Right. So then from the feature extraction, yeah, after extracting the pictures, or the features, and then will be go through the going to the decision making, yeah, or the classification, we can say, because this one we can categorize as the classification. Yeah. So then we classify the output of this process, yeah, becoming for example, rejection or acceptance, right? So if rejection means that it is not, it doesn't meet our standard, yeah. So the standard that given to the system, and accepted, yeah, if the condition is uh, meet the requirement of the system, right? So then rejection and acceptance. So these are the structure of the machine vision, and then traditionally, yeah, in the traditional environment, so visual inspection and quality control have been performed by the human being, yeah, or the human expert. And even though the human in many cases can do job, yeah, can work better than the machines, however, they have some weaknesses, yeah, for the human being. So as we can see here, yeah, human being tired quickly, yeah. So manual operator, yeah, by the human tired quickly. So very quick to be tired, yes, since the physical condition of the human also has some limitation. So then usually in industry we need about 2 hours. Yeah, after 2 hours, I mean 2 hours work, and after that for the inspection process. After that break sometimes, and then continue with the second process. Yeah, the next step. Yeah, after break 15 minutes and or 30 minutes. Then after that the human can work again, or the operators can work again to continue the job. Right. So tired quickly. And then the second one is slower than the machine. Yeah, of course, in terms of the processing, yeah, the human, yeah, we can say slower than the machine, because in the machine we can set up the speed of the process. Yeah, depends on the I mean the speed of the camera, of course. Yeah, in terms of the resolution. Yeah, the, what's that, the pixel? Yeah, I mean pixel element. Yeah, because so if the resolution is low, so of course, yeah, the speed also will be low, right? And then the next one is inconsistent. Yeah, as we know that a human being is consistent, so inconsistent. So we cannot say sometimes maybe we can measure or we can inspect the object clearly, but then after 30 minutes, maybe we have a different standard. Yeah, yeah, especially based on the visualization, yeah, or appearance. Yeah, so then it will be, yeah, of course, it will affect to the result of the inspection, yeah, in terms of inconsistency of the human being, right? But by using the machine, of course, we can set up the machines, yeah, with the certain value of the standard, yeah, was set the quality standard, and after that the machine will work, yeah, depends on the set up, yeah. So even though, I mean, we can set up even for 24 hours, yeah, the machine can work 24 hours, yeah, but the human cannot. Yeah, of course, the human has some limitation. Yeah? So the maximum usually only 8 hours working, yeah, working hours, yeah, per day. So then we need to to schedule the shift of the people, yeah, in order to cover 24 hours manufacturing processes. Right, so then required the training, yeah. So the human being, yeah, of course, we need to train the people, yeah, in order to perform some tasks, yeah, because of some tasks needs specific skills, yeah, in order to perform the task successfully. But in the machine, we just set up, yeah, and then also perform the training. But after that, the machine can work automatically. Yeah, that is the difference between the human and machine as well. And then the human skills may take time to develop. Yeah, that is one. Yeah, the machine, we can train the machine very fast. Yeah, but the human, of course, it takes time. It depends on the capability of the human being as well. Yeah, in order to capture or to catch the knowledge. Yeah, when they follow the training. Yeah, in order to perform the specific task. And inspection can also be tedious or difficult. Yeah. So certain people can identify, okay, this process of the inspection, yeah, is the difficult. Yeah. But for some other people, maybe they say, okay, this is the normal one. So then can be tedious. Yeah. Then can be even because of the human, mostly they cannot work in consistently. So then also be tedious. Yeah, so very fast to be tired. Yeah, yeah. So then the next, yeah, the machine vision are becoming increasingly popular. Yeah, it is because of the low cost maintenance and high accuracy. Yeah, the human, of course, then we need to consider the operational cost. Yeah, yeah, for the people. Yeah, daily, monthly, yearly, weekly, and so on. Yeah, but the machine one-time investment and the maintenance, so we can perform or the machine can work. Yeah, depends on the duration and the time of the operation of the machine. Right. And then the next about the related works. Yeah, many researchers have been done. Yeah, in the was it research related to the machine vision, so particularly for the surface defect as well as the flatness inspection. So as we can see in the following table here. Right, so the references as we can see in the left column here, so the authors, and then the second column is the methodology, and then next the application and the performance. The first one, yeah, by He et al., yeah, we can see that they use the curvature of lines, yeah, the edges of the shape, yeah, then link it together, yeah. So then to determine the size detection, yeah, the size measurement, yeah, of the objects, yeah. In this case, they use the bricks, yeah, for the objects, and the algorithm is stable, yeah, the performance. However, it has a small error in experimental part. And then the second one, Mati et al., yeah, they use the combination of the optical and tactile methods, yeah, in order to measure the surface, yeah, the surface defect here. And then the combination of the method has the better results than the generic methods, yeah, based on the previous method given. And then the Tian et al., yeah, they are using the active vision light scattering techniques, yeah, in order to measure the roughness of the objects. And the method obtains a good result, even though it is still a noisy, yeah, or a noise sensitive, yeah, the method. Right, and then Rosati et al., yeah, we're using the mirrors, yeah, to illuminate the left reflective component, yeah, and the application can detect the defect, yeah, for coated plastic component, and then the performance of this method, yeah, could omit the high reflection and define the defective components. And Usamen Tiaga here, they use the machine vision and laser beam technology, yeah, together, yeah, combine together and apply with the legendary polynomial fit. Yeah. The application, yeah, for the measurement of the flatness and the straightness, yeah, of the steel surfaces, yeah. And then the result, yeah, the performance is highly sensitive to noises, yeah, which reduce the, yeah, with effect to the performance of the system, yeah, in overall. And then Xu et al., yeah, to fuzzy for flatness used to control the algorithms in hot strip, yeah, and the result, the performance reduction of the flatness error significantly. Yeah, so they successfully reduced the flatness error, yeah, with the fuzzy algorithm and with the small steady state error and good stability, yeah, with the PID linear controller. All right, so these all are the previous work, yeah, have been done by the previous researchers, and then the background, yeah, the motivation, yeah, of the study. Yeah, the major problem of the existing method, yeah, there is no online robust method, so it's actually very, difficult to find a robust method, yeah, in this case, yeah, that has an ability to cover all physical surface defect. Yeah, that is the main motivation, because so maybe they have the surface defect method, yeah, or surface defect, physical surface defect inspection, but only for the certain part, yeah, not for general part or for all types of the surface defects. And then previous work have been specialized for the specific defect, yeah. Then some related works introduce a general method, yeah, even though it is not accurate enough, yeah. And then the second problem is how to develop a method to measure the defect and flatness of the ceramic tiles edges, yeah, accurately. And the method should be applied to the real-time system, yeah, online and accurate in this case. So these are the objectives of the research. So the first one is to develop an image processing algorithm, yeah, to cover the most surface defect, yeah, yeah, almost all. We can say the most of the surface defect of ceramic tile edges, yeah, such as welts and blobs. And then the second one is to measure the flatness and waviness of the ceramic tiles by using the image processing algorithm in this case. Yeah. So using vision-based system without extra equipment, yeah, or without additional sensors, yeah, just using the algorithms. And then is to develop, the third one is to develop an algorithm to calibrate the size of the ceramic tile. So then we can accommodate the size of the ceramic tile, since the ceramic tile sizes are various, yeah. So then in the market, so we cannot stick just for one size of the ceramic. So then we develop the algorithm that can be accommodated, yeah, according to the size of the ceramic tiles. All right, so then the next is the methodology. Yeah, as you can see here, the framework, yeah, of our system. Yeah, so we divide it into several parts here. So start with the image capturing. So as mentioned in the introduction also, yeah, image capturing actually is part of the image processing. So we capture the image by using the camera, and then after we got the image, then we proceed with the next part, yeah, or the next stage is the median filter here. So this is the first step. Yeah, the first stage, second stage, median filter. So in median filter, we use three kind of the edges detection, yeah, after the median filter. So the first one Kenny, yeah, the second one Sobel, the third one Previt. So Kenny, yeah, we use for the flatness feature extraction, yeah, and also the distance measuring. And then for Sobel and private, we use for the length measurement here. Yeah. So these are the tasks given to each edge detections method here. And then after Kenny, so we proceed with the flatness feature extraction here, which consists of the critical pixel extraction. Yeah, the first one. Yeah, the first method. And after that, we'll go through the best fit polynomial method. Yeah, in order to get the curvature measurement. Yeah, yeah. This is the first inspection. Yeah, flatness features extraction. Yeah, and then the second inspection is to measure the length here. Yeah, so then we use the Sobel and private. Yeah, so we combine this both method. Yeah, yeah. So then compare the best one. Yeah, then we proceed for the next step in length measurement, which is a morphology step here. Yeah, stage. Yeah, and then after the morphology, then we continue with the binarization. Yeah, and then after binarization, then by using the Kenny, so we can measure the distance of the object, yeah, or the length of the objects. All right, so this part we can say as the pre-processing, yeah, and then the last stage is actually the post-processing. Yeah, this is the classification. So in this case, we use the flashy classification because of we can use it. We can compare with the other method actually, but since we developed this one with the uncertainty, especially for the length measurement, yeah, because it involves the subjectivity of the measurement when we measure this object based on the appearance, yeah, or based on the vision. So then we implement the fuzzy classification. However, we can use any other classification technique, yeah, or we can even compare with the other techniques, yeah, in order to get the best result for the classification. Yeah. Yes. And then after classification, then we can generate which one, which ceramic is good, yeah, or accepted or uh, rejected, right? So this is the end of the process. Okay, so then in feature extraction here, so the first one is the flatness feature extraction. Yeah. So as we seen in the previous figure, yeah, previous diagram, yeah, pre-processing the source of the image. Yeah. So using the smooth and canny, yeah, and after that in feature extraction part, so we implemented the critical pixel extraction. Yeah, critical pixel extraction. So I'm going to explain in the next slide, yeah, for the critical pixel extraction, and then best fit polynomial method as well. Yeah, so after we got the result from the critical pixel extraction, so we'll be proceed to the best fit polynomial method here, and then measure the curvature, yeah, and then classify, yeah, here classification, yeah, actually. So classify the result, yeah. So whether it will be accepted or rejected. All right, so then the critical pixel extraction, yeah, here. So the first one in feature extraction. So the process is shown in the following image, yeah, or following figures. Yeah. The first one, yeah. So this is the drawing, yeah, the original image, yeah, original shape. For example, this is the curve, yeah, and the line, yeah, the diagonal, you know, or the slope, yeah, we can say. So then after that, yeah, we generate the pixel based on the original image, yeah. So then we got this kind of pixel, yeah. This is the first one, the second one. So this is the pixel generated based on the original image, yeah. And then after that, we categorize the pixel here, yeah, categorize the pixel, yeah, the first and the end, the first and the end, yeah, yeah, for the pixel, yeah, for each one, yeah, and then we determine yeah, or identify the critical pixel for each one. Yeah, so for example, this is the horizontal pixel. Yeah, and then this is vertical pixel. Yeah, this is single pixel. Yeah, for the slope. Yeah. So then after we identify this kind of the pixel, then we determine the critical one. So we just select the critical pixel for each shape, for each shape. Yeah. So for curve, yeah, for horizontal, and for, let's say, the curve. The slope. Yeah. So the slope. Yeah. This is, we can say, the horizontal one. Yeah. Slope, horizontal one, and this is curve. Yeah. Curve shape. Right. So then we determine each critical pixel for each shape. Yeah. So then we got this kind of the pixel for each one. Yeah. So we can say as the critical pixel extraction. So with this kind of the pixel, then we can generate the shape. Yeah. Yeah. According to the original shape. Yeah, as shown in figure one here. All right. So this one is figure 3, now 4 and 5. 5 is the result of the critical pixel extraction. Yeah. Right. So then the flatness feature extraction, yeah, the critical. After we got the result from the critical pixel extraction here, yeah, determine the critical pixel, yeah, yeah, for each shape has own critical pixel. Then we implemented the method of the interpolation polynomial, yeah, for the base width polynomial method. Yeah. Right. So then we use this kind of formula, yeah, in order to perform the interpolation polynomial k equal to d power 2y. Yeah, this is the absolute value. Yeah, absolute value for d. Yeah, d power 2y over dx or 2. Yeah, and divided by the in the bracket, yeah, the second one, the second equation here. Yeah, 1 plus dy over dx, yeah, square or power 2, and also power 3 over 2. Yeah, so this is the interpolation polynomial uh, applied in our method. Yeah, yeah, for the second one here, the best fit polynomial. Yeah. All right, so then we can determine the measurement of the curvature. Yeah, this is the curvature measurement. And then the hardware installation, as you can see here, yeah, in the picture. So this is the ceramic, yeah, ceramic tile, the object, yeah, or ceramic tile. And then this is the camera. So we use the normal camera here, yeah, the webcam. So even low resolution, yeah, because of we find the normal one, so it is available in the market, so easily to find in the market. And then we set up this camera, yeah, the distance between the camera and the object, yeah, here. So it's about 17 centimeter. So you can adjust this one in order to get the best capturing image, yeah, the best image captured by the camera, yeah, because of it depends on the resolution of the camera as well, yeah, the distance and also the focus of the camera, right? And then we should put the black background here or the dark background, yeah, in order to compensate the lighting effect of the environment, yeah. So instead of putting the also the lighting, yeah, we also provide the black background, yeah, black background for the image capturing, yeah. Yeah, so then this object are on the top of the conveyor belt, yeah, which is moving from this side, yeah, to from left side to the right side, yeah, we can say. So then the speed of the movement also we can adjust, yeah, because there is a adjustment of the moving conveyor, yeah, conveyor movement, yeah. So then it depends on the capability or the specification of the camera, yeah, because if it is too fast, then maybe the camera cannot capture, yeah, clearly the object. Yeah, so then we can adjust this kind of the speed. Right. So the layout here, yeah. So the illustration actually the same as the before, yeah, as before as here. Yeah, only this one illustration, yeah, the drawing. Yeah, and then the result, yeah, we can see here, yeah, with the source image, yeah, and then the smooth and canny, yeah, process, yeah, here. This is the source image, you can see. This is the original image, yeah, original. So then after applying the smooth and canny, yeah, we got this result. Yeah. So this is not original. This is the image resulted by the smooth and uh, canny algorithm. Yeah. Yeah. So this is after smooth and canny. And then the next one with the critical pixel. Yeah. So this is with critical pixel, we can get this image. Yeah. So then only determine some pixels, some important one, very important one, very some critical pixels. So that's why we got only some pixels here. Yeah, yeah, determined by the this kind of method, critical pixel extraction. So then by this kind of the pixels, so we can generate, yeah, connected all these pixels to be the shape of the original object, right? Yeah. Okay, then after that, uh, apply the best fit polynomial method here, right? With this kind of the formula, yeah, yeah, this of the best fit polynomial. Then we got the measurement of the curvature. All right, so then the result of the tile with flatness defect, yeah, the surface flatness, yeah, it's a surface defect, yeah, in this case it's flatness. So we can see here, yeah, this is the x and y, yeah, and then the curvature value, yeah, for each one based on the pixel given, right? And then this is the tile with weld defect, yeah. So as you can see here, yeah, this is the original image, yeah, original one, yeah, and then this is yeah, after we implemented the smooth and canny, so then we can see the defect of the object here. Yeah, the weld defect we can see. So then after that with the critical pixel, yeah, here. So then we can determine only some pixels, some important pixel or some critical pixels, including the defect. Yeah, the defected pixel here. Yeah, due to the weld defect of the object. Right. So this is the curve of the object of the ceramic tile. All right. So this is so these are the result of the tile with the weld defect. Yeah, as you can see here, x and y. Yeah, for the question the length of the object, and then the curvature value. Right. So this is the weld defect. Yeah, as you can see. Yeah, the graph. Yeah, the curvature value will be more than the normal one. And then this is the normal ceramic tile, yeah, without defect, yeah, without any defect. Yeah. So as you can see here, non-defective ceramic tile, the original image, yeah, the first one, yeah, and then with the what's it, the smooth and canny, yeah, yeah, with the filter and edge detection, and also the last one is after we apply the critical pixel value, yeah, yeah. So we got some pixels, yeah, yeah, representative of the object overall. So then we can generate the original object based on this critical value only, this critical pixel value. And, and then for the curvature of non-defected ceramic tile, this is the graph here of the curvature of non-defective ceramic tile. And then for the result of the length measurement, yeah, we can see here. So the source image, we will go through the smooth and private and soft bend. Yeah, as you know, the previous one for the curvature, yeah, or the flatness. We use the Previt, yeah, but I sorry, Kenny, yeah, but in length measurement we use the Previt and Sobel, yeah, and then we will go to the morphology, binarization, and after that the measure. Right, so this is the original image, yeah, yeah. So we are going to measure the distance, yeah. So by using uh, both techniques here, yeah, morphology and binarization. So we can generate this image, yeah, the first one and the second one. So based on this point, yeah, 2 point, yeah, end to end, we can say. So then we can measure the distance of this object, yeah. So this is the principle of the algorithm that we applied in this kind of process, right? And these are the result of tile length measurements, as you can see here, the accurate length. Yeah, and when we use the Kenny, yeah, the error, yeah, when we use the Kenny and the software, the error, and the Previt, the error. So then we can compare, yeah, among three kind of the detection, yeah, edges detection in this case, and then we see the error of each detector. And then the summary of the results, yeah, the evaluation of the proposed method is carried out on 200 ceramic tile borders, yeah, in this case. Yeah, so we just taken 200 ceramic tiles, yeah, and then Fazimam dan Kaswin applied to sort the ceramic tile based on the result of length and curvature measurement in this case. And then the result shows 97% of the ceramic tiles had the surface defect, yeah, so can classify the ceramic tiles, and 97% had a surface defect such as a welt, a blob, yeah, and it is, I mean, the right classification. Yeah, we see the appearance of the ceramic tiles, and in addition, 93% of the ceramic tiles with flatness, yeah, and waviness defect were recognized. So we can say the accuracy, yeah, to detect the uh, flatness, yeah, or surface defect was 97%, yeah, for the ceramic tiles. And then the accuracy to detect the flatness and waviness, yeah, this is for the defect, yeah, defect like surface defect like weld blob, yeah, 97%. And to detect the flatness and waviness, yeah, was 93%, yeah, the accuracy. All right. So on the other hand, the length measuring is also found to be accurate enough. Yeah, the length measurement also accurate enough, yeah, to measure the length of the ceramic tile borders. Right. So then this model is able to cover border defects or edges defects, yeah, such as the edge curvatures and weld defect, yeah, for the ceramic tile. Yeah, and then the method is presented to measure using the length of the ceramic tile. Yeah, and then for weld and flatness defect, generic method, we suggest the generic method. And this proposed system would cover edge detect problems efficiently. Yeah, right. So these are the main references that we use. Yeah. So because we have many other references actually, so only this part that we have shown, yeah, in this presentation. Right. So that's all my presentation, and thank you very much for your kind attention. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh, and the time is given back to the moderator.
Thank you very much, Professor Anton. Let me conclude the presentations. Image processing for sorting tiles or sorting machines. We talk about rejections or exceptions about well detect of the tiles. Even though human in many cases can do better than machines, but they have some weaknesses like tired quickly, slower than machine, inconsistency, and machine have an advantage such as low cost maintenance and high accuracy. Thank you very much, Prof. Anton. And we move forward to the question and answer from the audience uh, here in this room and audience in the Zoom meetings. You can raise your hand in the Zoom meeting or you can use chat. Okay, Mr. Dimas, Dr. Dimas. Okay, you can directly give a question to Professor Anton.
Well, thank you very much for the opportunity, Dr. Mahendra. Assalamualaikum, Professor Anton.
Waalaikumsalam.
Yes, okay. Okay, thank you very much. Very nice presentation. Well, actually, my name is Dimas Arif Rahman, so I have two questions for your nice presentation. The first one, I see that the accuracy of the performance of the fuzzy classification using the Magdalene is quite high, 97%, but my question is that possible to use the similar classification to further fine grain classification, not only to detect or to decide whether this one is defect or not, but further determine what type of defect, for example, well, and also the other type of defect. And my second question is about the length measurement. I see in the result that using Candy software and private, the result is quite yeah, for me, actually for me, it's a bit difficult to interpret. I mean, like sometimes private is better than any, and software sometimes is software is the best among the two. Would you like to explain more when what the condition of private will for the best result compared to two when private and so the other training is more suitable, yeah, compared to software or private. Yeah. Thank you very much, Prof. Anton and Dr. Erwin.
You're welcome. You can directly answer the question from Dr. Dimas, Prof. Anton.
Okay, thank you very much for the very good question. Right, so the first one, yeah, from the Dr. Dimas. The first one about the fuzzy classification, classifies. So we use this fuzzy. Actually, we have to consider about the object and as well as the data that are provided by the object. Yeah, I mean, what kind of the data that will be the input of the process. Right. So in this case, we measure the length. Yeah. So then sometimes in terms of length, yeah, we cannot precisely measure. Instead, I mean, unless if we use the measurement device. So if we use measurement device, of course, we can get exactly the length of the object, right? So even though we use the what's it like the sensor. So the sensor also based on the estimation or prediction, yeah, not exactly 100% as the original object length, yeah. So that's why we use the fuzzy because of there is involving the uncertainty in this case, yeah. So we use the fuzzy even though yeah we can use any other classification method, yeah, in machine vision, yeah, like neural networks, yeah, and also KNN, yeah, SVM, yeah, and so on. So, however, it is or it depends on what kind of the object and what kind of the features or attributes that we are going to determine in this case. And also, yeah, so that is the one. Yeah, of course, it can be improved. Yeah, if we perform the the development of the other methods, yeah, in classification, yeah, like I mentioned, yeah, using machine learning maybe. Right, that is the one. And then the second one, yeah, about the Kenny, private, and software. Yeah, based on my experience, yeah, was if you use to measure two dimension, yeah, two dimension measurement for the object. So Kenny is the best one. Yeah. So especially for rectangle measurement. Yeah. Rectangle measurement with two-dimensional. But if the object is different, yeah, different shape, yeah, or different types of the object, then of course it will be having the different performance. Yeah. So that's why for the circular or circle object, yeah. So maybe we use a different method, yeah. Or for 3 dimension, of course, we use the different method, yeah, because of the approaching, yeah, of the measurement will be different with the rectangle. Rectangle is among the simplest one, so that's why with the Kenny, yeah, we can say the Kenny is the best one for this kind of the measurement. But if we used to measure different types of the measurement, yeah, and different types of the object, like a 3 dimension object or the circle, yeah, yeah, or the circle with, I mean, the uh, with the different skewness or kurtosis. So then we'll use a different kind of the method. Yeah, but for the simple one, Kenny is the best one. Right? So that is my experience in this computer vision research.
Thank you very much, Professor. Any other questions from the audience? Okay. Okay. So Kenny is the best one, two-dimensional and rectangles. For circle or any other objects like three-dimensional, maybe we can use different methods. We can use many methods in the classification, such as fuzzy, KNN, or SPM. It's depend on the what kind of data or object that we will classify. That's correct, Professor? Yeah.
Yes.
Thank you very much, Professor Anton Satria Prabono, for outstanding presentations. Very nice topics and idea for this afternoon sessions. Thank you very much.
Thank you.
And discussion from the author of the mission paper, our first day parallel session, in which the audience will part into 2 rooms, which is Jasmine sits in ground floor and Zara 2 in the floor, which is this room. And this session will last for 90 minutes, and we will gather in this room later at 15 past 30. In this session, there will be moderators that will be accompanying both rooms. Therefore, we as a master of ceremony give the moderator the opportunity to lead the parallel session. Thank you.
Okay, thank you so much. For all the participants are allowed to go to their each rooms that already divided before. Thank you so much.
Langsung laptopnya itu.
Terus.
Oh, ya oke. Lihat sini.
Assalamualaikum Prof. Anton. Thank you very much for the presentations, and now we can move to the parallel session. You can stay as you wish.